Hello everyone, thank you for coming. I'm Strahinja Janjusevic, master's student here in Technology and Policy program. I'm going to be talking about guaranteeing agency in the age of neuroprosthetics. So the idea is that very soon we'll move away from these traditional prosthetics that we've seen around to something more futuristic, such as AI-powered prosthetics that interact with our neural system and that can predict, analyze, and help us do more complex movements. It's something that Rachel talked about and a lot of experts are working on. But I've seen this in an even more reliable source in our fiction, where we moved from Captain Hook and Hook prosthetic to something more futuristic like Cable in Deadpool. On a more serious note, I come from a military background, and for all my military friends here and veterans and everyone else in the room, I want you to think about a person that you know that through some unforeseen accident has lost a limb or became paralyzed. The face and the picture of them having regained the ability to do the same things again is what motivated me to tackle this problem. But as I also come from a cybersecurity background, I couldn't help but think, what if one day they were using this AI-powered prosthetic and out of nowhere something like this happened? Their arm or leg, while they're playing with their kid, got completely disconnected. And this can be due to the company or hacking, but because of this, they will go through that event of losing this agency again. So this is what I want to prevent. And in order to prevent this correctly, we have to answer the underlying questions. When the software crashes, who owns the limb? So to emphasize this problem, today in America, there's 2.3 million people that have some kind of limb loss. And this number is projected to be double by 2050. Also, there's 302,000 people with some kind of spinal injury, and this number grows by 18,000 cases every year. And besides the moral and physical net gain they will gain, there's also an economic one. So currently, we are spending over $5.8 million per patient that has a severe tetraplegic case in their lifetime. On top of that, the traditional prosthetics try to solve this, but the upper limb ones are being abandoned because of the cognitive hardships of us using them. So AI-powered prosthetics will allow us to walk, grasp, speak, see, hear, feel again. And these are just some of the cases. But why now? The answer is actually closer than you might think. So some of you might have used this technology called ChatGPT. The technology underlying ChatGPT is actually the same technology that will be powering the term I coined, generative moral policies. How they work is the same way that ChatGPT processes words, converts them to sequences, and then predicts the next sequence. The same way the generative moral policies would take the intent, the neural spikes, convert them to sequences, and then predict what we want to do. And this will completely redefine how AI is used in healthcare. So we will move from doctors using ChatGPT, for example, to analyze diagnosis or give a diagnosis to something that's completely integrated with us. And now I know everyone felt the pain if you run out of usage using ChatGPT and not able to do anything. Now imagine if your leg runs out of usage and you're not able to walk anymore. I know this sounds like science fiction, but actually there's a case close to this where a company called Second Sight was making this product called Argus 2. And what it did is a bionetic eye that would take pictures of the environment, and it would help people that lost their vision kind of see again. And one of the first customers, Barbara Campbell, was one day in New York at a subway station, and she heard the phone beeping, and unfortunately, her eye powered off. So now imagine if both of her eyes were substituted with this. Unfortunately, this is not an outlier. There's other cases too. So in 2017, after that, about pacemakers had a firmware flaw that needed to be replaced. So FDA recalled 465,000 devices. In 2019, kind of the same thing happened with a cybersecurity issue when Medtronic had to replace 4,000 US patients had forced to switch. And then lastly, second side, the same company that was producing Bionic Eye, powered down in 2020, and then 350 patients that were using it were left stranded. No one was able to update their firmware. They didn't know what to do with that limb. We have to prevent this from happening with generative model policies in the future. So in order to do that, I've identified 3 modes of failure that we might encounter. First one, in the case of company going bankrupt. In that case, what do we do? Who is supporting the hardware? Same kind of goes with ransomware. What if company gets hacked and is not able to provide support for that device anymore? And lastly, in the case of subscription drift, if the company itself decides to raise their prices and you as a patient are not able to pay for that subscription anymore, how do we ensure that the user still has the availability of the AI prosthetics? So that's why I propose the newer ESCO standard. This standard is built upon 2 pillars. First one is a local first sovereignty. What that means that the minimal viable function of every AI prosthetics has to be always available and running on edge device, as Rachel mentioned. Only communication to the cloud would be for some enhancements. How can we test for this? If we are offline, somewhere in the woods, and if we can use the device, it's good. Second pillar is a right to repair trigger. What this means is in the case of a ransomware or company going bankrupt and no one being able to support the customer, all of the model weights, compiler keys, source code has to go open source under the license to maintain and update. This is for a reason so that third parties can update their own software. So to emphasize, generative model policy has to always run on the edge device. Calls to the cloud are only made for the enhancements. The goal of this is for subscription to be only a gate for those enhancements, but the minimal viable function cannot be a subscription tier. You can think of this as any ability to walk, grasp, speak, or anything that's essential will always be running on the edge device and processing there, while something like recalibration, personalization, skills updates, if you want to see through the walls, that can be a subscription-based. Second, some might ask, oh wait, but if we open source it, is that a security issue by itself? And this is actually empirically false. And we have 2 cases to prove this in healthcare. So one of them is the pacemakers I was talking about before, where that vulnerability that was found in them was actually found by the open source community. They reverse engineered the device and recommended for its approval. And then the second case is an open source artificial pancreas that demonstrated equal safety but better performance than its closed source counterpart. So another question that might arise is, in a case of open source again, what happens with the IP? How would these companies be incentivized then to solve this problem? But the NeuroESCO standard is not a general public license. The patient holds the benefit and the estate keeps the IP. The goal is, on a trigger event, to have this code released, but only under the maintenance license, not for commercial use. The IP and copyright stays with the company that built it. And then FDA would have to oversee and regulate all of those cases where the maintenance did happen. as well as build a regulatory body that will work on problems where not enough of open source community are located. So for example, if a neuroprosthetic is so niche that there's not a lot of people that can work on it, then in that case, government will step in and try to help in those cases. And if we manage to implement this correctly, then finally, in the end, we'll be able to answer the question, when the software crashes, who owns the limb? The patient does. Thank you.
Thanks, Straho.
Hi, thank you. Do you have any information on the preference of the patients that this technology would be implemented in terms of their autonomy? I'm thinking about like what you referred to as like the fancy springs versus say like a leg that you have to like plug in every once in a while to charge. Mm-hmm. I'm also thinking about like the number of occupational therapists and physical therapists that assist these patients in regaining some of their autonomy.
Yes, that's a great question. I think it will depend a lot on the prosthetics that is in place. The new ESCO standard is mostly imagined as a high level to affect all of the AI prosthetics that are going in the future. So it's hard to answer that right now until we see how that will develop in the future.
So just thinking about these prosthetic limbs, you're saying it should be open source, which is great, and that all this certification and regulation should come through the FDA. The FDA is famously under-resourced and cagey about touching things that have to do with AI in a medical setting, right? Yes. A lot of them don't even qualify as SAMD at this point. Yes. And when they do take down, sort of abusive companies like Theranos, they don't do it. They tell the FCC, well, if they lied to us, they lied to their investors. You go get them. Yes. How are you going to have the resourcing to do any of this, which is, I would say, a requirement, right, for having these more advanced limbs?
100%. That's a great question. I think that in the future, the market will shift that way, and when they realize what the net gain of this is, right, the problem will be more emphasized over time, and of course, on the economic side, but also on how many people are affected, that the FDA might have to shift their focus and be more helpful in that way. So I think they'll just need to change in the future.
Great. Hey, great talk. David Otter, another economist, still glowing from the previous compliment. I think the problem you're addressing here is profoundly important. I'm concerned, as Marjane Ghassemi is about asking the FDA to solve this problem. Let me just propose an alternative idea. Why not force companies, when they put these products on the market, to buy an insurance policy such that if they shut down, there's a third party that is effectively responsible either for maintaining the device or perhaps replacing it with some more modern model. That would add to the cost, but it would provide another type of fail-safe.
Yeah, I think that's an amazing idea. And the reason why I wanted to tackle this here and present is for amazing people like this to give a comment. And we can think about this together.
Great. Brian.
Thanks. So your third risk was subscription drift, surge pricing, companies jacking up the prices. I mean, of course, that's a big issue, but I'm wondering whether you think there's much new in this case, right? We have this with prescription drugs, which in some cases might even be more important. They might be needed to sustain life, where we worry about companies who have patented the drug, then down the line raising prices iteratively, and that obviously puts real strain on patients. Yes. So I don't have the solution to that problem, but I'm just wondering whether you think there's something new here, or whether you think, look, we just need a blanket solution somehow to this issue where we want the private sector involved in healthcare and developing drugs, prosthetics, and so forth, but we also want to make sure that then people don't come to rely on them in a way that leaves them vulnerable to companies then raising prices. So is there something new here?
Well, I think that's a great question. Thank you. I think this is a little bit of a different case here because we can ensure that the minimum viable function is still running in the case that company jacks up the prices, right? With the drugs, that's a little bit harder to do because you either have the drug or not. So I think that's why here in this case, it might be a little bit a different type of problem. I think this is more analogous to large language models now, where you always do have that option to go back to something worse that still works somehow, right?
Great.
Thank you so much. I have a question about how to think about the right to repair. So there's an old thought that rights kind of come in thick and thin varieties. So there's a sense in which I have a right to buy a penthouse. There are no legal impediments to me doing so in some thin sense. But of course, I lack the ability to actually exercise that right. I don't have access to the required resources. So I could see how the sort of ideas you had could guarantee a right to repair in this very thin sense, but it seemed like they fell short if we thought about the right to repair as requiring like a meaningful ability to actually do so. I mean, presumably many of the people who might find themselves in the sort of situation where their limbs stop working are going to like lack any practical ability to, you know, look at the open source code and repair on the basis of understanding what's going on with the open source code. And it seems like if you don't have a right in that thicker sense, then you might think, oh, really, there's not really ownership of the limb being guaranteed in these kinds of failure conditions that you're thinking about.
Yes, that's a fair concern. I think we overall keep underestimating the open source community. And as you saw in the pacemaker example, it was actually found by someone who might not have that pacemaker, but might have known someone who did, right? I think open source communities, and I see it in the cybersecurity all the time, able to fix a lot of things. And there's a lot of good people out there that look at these problems, and especially in case of something that limits someone's movement, I'm sure that there will be some engineers that are looking at this stuff. And in the cases where there is not, because the prosthetic is so niche and used by not many people, there should be a government agency that will be trying to look into those cases specifically.
With great power comes great responsibility. With right to the limb, presumably also comes liability for the limb. If my limb causes an accident because it steps on the street and a car needs to swerve out of the way, am I responsible? Is the manufacturer responsible? Who is responsible?
That's a great question and a hard one, because I feel like we're experiencing that right now here with large language models, where we don't know who to hold liable. And honestly, it's hard to answer that. I think, in my opinion, personally, is the company who built it, but and not the patient, because they did make the algorithm in the beginning, and they hold the IP and the rights to it. So,
great. From over here, Strahinja. Over here.
Thank you so much for a great presentation. A quick question when it comes to right to repair and the open source things. Sort of where would you draw the line, right? Would all the subcomponents that go into a limb have to comply to it, or would the limb sort of more as a whole have to comply?
Yes, amazing question. Thank you for that. I think it depends who builds the limb, right? If this market goes to that space where different components are built by different companies, then it's a totally different question here, and it's harder one to answer. If it's like one company that builds all of the components, then yes, all of them should be complying to this standard. Yeah.
Do we have further questions? You can be brave, you can speak up. Yes. Sandy.
Thank you for your talk. So in the beginning, you did this gesture of saying, you know, the Captain Hook example, we're not going to take that seriously. But there's a recent episode in the recent season of Black Mirror that reinforces everything you're saying about subscription drift, right? So I think it's important to think about how things like the arts and science fiction is already doing the work of imagining what the ethical implications are, right? Because the ethical implications are about projecting yourself into the future possibility of what AI might do. So I think it is important to take some of these fictional works seriously because they are doing the work of reinforcing what you have claimed here.
100%, I agree. Thank you.
Yes.
So thanks so much for a great talk. So I have another question on the sort of open access and so forth. So the norm thus far, I think, in the computational world has been that having the ability for communities of hackers to be able to find flaws in systems usually works for the social good. But in a context where we have more and more powerful AI agents that may be under the control of some firms that we know, but increasingly maybe others that we don't, it seems that there could be some slippage or some drift from that previous norm of a social good in terms of having open access. How should we think about that kind of problem?
Well, in my opinion, and that's going more onto the AI agent and AI safety side, I think open source is always great. I think the people should be the ones that decide how the technology is moving forward and not the companies. That's just my opinion. But I think it will apply here as well as in the case of AI agents.
Okay, well, thank you very much, Straho.